Hello. Welcome. My name is Jonathan Pulsifer. I'm a security engineer at Shopify, and today I'm here with a couple other folks and whom I'll introduce momentarily. But we're going to talk to you about keyless entry, that is securely accessing Google Cloud Platform services from within Kubernetes. Before we get started, though, I'd like to just mention that we have a Dory here. I've not used this before. Good luck. If you would like to ask us some questions, this is how we can do this. But also, we're going to have a pedestal mic to take any questions from the audience when we're done. So again, hi, my name is John. I'm a staff infrastructure security engineer at Shopify. I like to hang around with Mike and other folks on the Kubernetes Product Security Committee. And I'm a Google developer expert for the cloud platform with a focus on security. Before coming to Shopify, I got my tinfoil hat in the Royal Canadian Navy, where I'm a self-described SIGINT cyber sailor. So that's where that came from. And previous to that, did a little bit of instructing for the SANS Institute in cybersecurity. You can find me on the internet, John Pulsifer. With me here today, we have Aaron Small, who's a PM that is product manager for Google, a GKE in Kubernetes security. He works on identity things. And has recently pushed out the third-party audit for security for Kubernetes, which is really, really neat. So look him up and look that up. I think it's fantastic. Previously, I used to be a PM for other places, and I wish I could bake as well as Aaron can. My bread doesn't turn out as nice as his these days. Aaron cares a lot about the blast radius of things and trust, generally. Mike Denis, who you may know from the Kubernetes community, is a software engineer at Google and works on GK security. He's a chair of the Kubernetes Special Interest Group for Auth, that's SIGAuth, and is the tech lead on GK identity stuff and likes Seattle a lot. So before we dive into the meat, I have a little bit of a story to tell you. Before we get into the story, I'd like to thank the folks at Bright Carbon for turning our diagram into what it was before into what it is now, and that's very pretty. And we use this to talk about Shopify. So Shopify, for those who don't know, is a multi-channel commerce platform that on Google Cloud Platform now has over 50 GKE clusters in production that power over 800,000 businesses in 175 different countries. And we allow people to sell things to people. The people who sell things are everyone from me, my grandmother, and then big brands such as Kylie Cosmetics, Allbirds, and a lot more. So meet Emily. Emily is a dev degree intern at Shopify. The dev degree program is like a work-integrated learning program that takes university students, first-year university students, and puts them on the fast track to being developers that are really impactful. And we do this by like layering on personal development skills and technology stacks like the ones we use at Shopify, primarily Ruby on Rails, feedback loops, and other things to really help them grow and become developers. It's like a really intense co-op program, right? And she's doing all this stuff on top of a degree, right? For someone who doesn't have a degree, I think this is really next level stuff, and I just don't quite understand it. I don't think that I could work as hard as she does. But in any event, Emily is studying her first year at computer science at Carleton University in Ottawa, and we help her build cool things. So in just a few clicks, Emily is empowered to create new things. She explores her ideas. She doesn't have to reason about debugging our production stack. Like it just works, right? And with a little familiarity, maybe like a breeze through the documentation. I mean, who reads those? Emily and other developers like her, Shopify, can really deploy like a fresh Ruby on Rails application that's completely configured, everything from Cloud SQL, Redis, Memcached, protected by our implementation of an identity-aware proxy that's Minerva and the cloud bosses and the other friendly Kubernetes controllers that keep our cloud fluffy. The pieces of the cloud that I want to highlight today are the ones that reason about identity. And one that we haven't really talked about before, the pieces that bootstrap our cloud runtimes is ground control. And ground control was missing from our previous diagrams because it was just like one of those things that you thought would go away, right? we built it, and it was like pretty resourceful. It was quite scrappy. But then it turned out to be like a critical part of the production stack. And so I figured I'd talk about ground control as it relates to the larger identity problem at Shopify. So the parts of ground control that are really important are the initialization of the Kubernetes namespace, the generation of the asymmetric key pair for encrypted JSON. That's where our developers store our secrets. You can find that at GitHub Shopify eJSON. And the last piece, the part that relates to today, is the creation of the Google Cloud Platform Service Account identity. So this is like the genesis of identity for a service at Shopify really happens at ground control. So some other controllers that help keep the cloud fluffy at Shopify, these are the cloud buddies. We really like to talk about the cloud buddies because it takes away all of this technical complexity and makes it more friendly. And so these are my favorite ones. Thanks to David Neal for bringing the cloud buddies to life. NetPol Buddy ensures that our Kubernetes network policy objects are in place. RBAC Buddy does the same thing for Kubernetes RBAC. Bucket Buddy really helps us lifecycle our GCS buckets. And Accountability Buddy, my favorite, grants IAM bindings for GCP APIs and binds the service accounts to be able to access these things. So Google service accounts are something else, right? To use an East Coast expression, they're right out of her. I'm from the East Coast of Canada. I don't really like to use $12 words to express myself, so you'll find I use a lot of colorful, concise, and expressive language to do that. And so the few things that I wanted to highlight about Google service accounts, and that is to demystify them, is that, one, there are two types. You have the Google managed service accounts, and you have user managed service accounts. The Google managed service accounts are the ones that you'll find in your IAM page that look like your project number, which a lot of people don't know, at a Google product project.im.gserviceaccount.com. You can't generate credentials off these. These are the robots that keep Google's cloud fluffy, and power the ship, as it were. The user managed service accounts, the user managed GSAs, are the part that's hard. And I want to talk about why they're hard, and hopefully you will come out understanding that they are difficult to manage as well. So the second part of that is that the keys are not well understood, right? We have this documentation in the cloud platform that says, like, hey, look, security bits. Let's just create this JSON blob and jam it in this Google application credentials environment variable. Quick hands up. Who can explain to me? Sorry, audience participation is definitely going to happen today via me and Aaron and the whole works. So hands up if you can explain to me all the technical bits that power Google application credentials. It's like, so we get like the security PMs. We have one, like, and that's it, right? That says all that it needs to say, does it not? It's just a fun security bit that you throw over the wall to the security team and say, yeah, have fun, right? The last piece that I wanted to highlight is that it works, thanks. Shopify is left infosec, right? And we provide a lot of support to our developers. We have over 1,000 developers at Shopify, and they don't know how service accounts work either. And so we have to help them figure out this maze of credentials and identity and access management and what it all means, right? Thirdly, the keys are unreasonably hard to manage. And I say that because buried in the documentation says, in other language, that you should really, really, really not use Google or user-managed service accounts unless you have the following in place. And again, hands up if everyone knows how to fully manage a PKI very well, right? We have a few again, but we've all created a CA, right? We've all created the self-signed CA, but what about managing CRLs at scale or OCSP? How does that all work and where does this all fit in? These are core competencies of a PKI that's actually required if you are to effectively manage thousands of these keys, right? And so that's the really hard bit. It's not easy. And that's what I want you to come away with today. So user-managed GSA credentials live forever, right? 10 years is forever in cloud years, by the way. And they're actually technologies that we're familiar with already. They're typically, in the JSON blobs, a 2K RSA key pair generated off the PKI that is your project. And the common name is its unique ID. So if you think you can just like delete things and use those certs again and come back, it just doesn't work. There's a lot of nuance in that, a lot of PKI nuance, and it's not easy. Shopify found out that we push the limits of a lot of the products in Google Cloud Platform because we poke at the bits that people don't expect us to, the PMs don't really expect us to. And we found out the hard way that when you reach 1,000 user-managed GSAs per project, that IAM doesn't let you list them anymore. And so given that it's like a slight denial of service against IAM, we got the feedback that we should probably do something else. And so now we have multiple projects which only hold GSA service account credentials. Like, that's wild, right? And how do you like reason about these things? Are we confident that these credentials aren't misused? An employee that left had a hot exit, you know, are we confident that any keys didn't go along with them? We generally do a good job at auditing these things, but there are just a lot of keys that have grown with us through the years that I would deem as sensitive, and we'd like to do something better, right? We'd like to change. And so, given all of this doesn't include identities for like the instances or the nodes or the GK node pools. This is just like service accounts that have been created for applications that run on our cloud platform. This is not the rest of them. These like 1,200 so service accounts that I mentioned are just for services. So we, in fact, have a lot more. So all that to say is that containers that run at Shopify and our cloud platform are experiencing what I would call as a conflict of identity. And you know, we've created these cloud buddies, and there are other Kubernetes controllers and some other automation. We're a software company. We create cool things to help solve our problems for us. But scaling does come with its challenges, right? Like over 1,000 service accounts per project thing. So the product that you're about to see, the technology that you're about to see, really hopes to address a lot of these problems and further like consolidate the identities of workloads, bridging trust domains, as it were. I mean, in Kubernetes, we would just call this a namespace, right? If we could just namespace a series of identities, wouldn't that be neat? But who am I to say? So with that, I like definitions. I like these $12 words and expressions. So Aaron will give you a lot more of these, or a few more definitions. I stole one from him, and it's this one because I think it's really important. So we do a lot of talking about workloads today. Workloads are everything, everywhere, and what I mean by that is that they are software running on a computer. They are containers. They're binaries. They're just a thing talking to a modern authentication system, right? And so workloads at Shopify, including human workloads, leverage short-lived signed JWTs, JOTs, as it were, for tools like gcloud, kubectl. All these tools use these technologies, and so the impact here really is that we interact with these technologies as humans more than we probably realize that we do. It powers accounts.shopify.com. That is our identity application at Shopify. Every OAuth 2 proxy that you've ever used, the Bitly OAuth 2 proxy, BuzzFeed SSO, the whole thing, and Google, right? So it's largely my opinion that we should be consolidating these identities. We should be consolidating all these technologies and using them just as everybody else is. So with that, I'm going to hand it over to Aaron, and he's going to show you something new.
Thank you. I'll see if I can figure this out. So as I was getting ready for this talk and putting these slides together, a lot of the feedback I got from my peers was that I tried to cover too many complicated topics in the time that I had, and I didn't go into enough depth on any given one of them to actually explain it in full. And they were right, but I think that actually points to a bigger story, and that bigger story is that identity and credential management is hard, like capital H hard. It's a really deep space. You have to worry about credential issuance and distribution and that long list that Jonathan listed off earlier, and revocation and auditing and renewal and exfiltration protection. That's my first $12 word. and replay protection, and on and on and on. If you add to that the alphabet soup of all the standards you have to deal with, like OIDC, JOTS, RFC 7518, and then you layer on top of that all the unique authentication and authorization systems that each cloud provider implements, I could end up talking for like 2 hours when all Emily asked was, how do I access cloud storage from GKE? So I did the work to simplify the presentation. We won't cover my favorite RFCs and their finer implementation details, but more importantly than that, I think we simplified the practice. Jonathan from Eastern Canada addressed these problems with some really heroic engineering and actually shouldered some of Emily's burden, and he definitely made Emily's life easier. I want to take a step back and look at how this works for the rest of the world, though. Except I'm from a big old West Coast city by the bay, and I'm going to use as many $12 words as I can. So the first thing you do is you go to IAM, and you create an IAM service account. Then you download its key, and when you download that key, you get this lovely little warning, and it's perfectly accurate. Like, don't get me wrong, you should read it carefully because it's perfectly true. And then you have all these keys, and this is actually a screenshot from one of my own personal accounts, and I have a very good reason, I assure you, for having this many keys downloaded, but I'm not going to tell you what it is. Once you have this key, you run some kubectl commands against it, and you end up with a Kubernetes secret. And then you can update your Kubernetes YAML files with this secret, and you have to mount it in places that the Google Client Libraries know to look. And that's pretty much it. Once you mount this secret in all the right places, your Kubernetes workloads know which identity to use when talking to Google Cloud. And at first glance, there's nothing really wrong with this approach, right? Like, from a strict threat modeling perspective, as long as there's no vulnerabilities anywhere in your application or anywhere in Kubernetes or in any of your dependencies, it's probably fine. Kubernetes handles secrets in really rational ways. It's not going to accidentally expose it to the wrong workload. However, manageability gets quite complex. If you have thousands of these keys that you're managing as individual secrets in various Kubernetes clusters, you would have to build a system to manage them. And then furthermore, if it does get compromised, if someone does manage to get their hands on one of these secrets, they can exfiltrate it. They can take it with them. And once they have it back home, they can use it to perform whatever malicious action they had planned until either you notice or until it expires in 10 years, which I guess is forever in Cloudland. So this all comes down to this concept of blast radius. And security professionals like me always talk about blast radius. But what this really means is, let's first assume that something's going to go wrong. When this thing goes wrong, what else breaks? And I don't mean what pieces of your application stop working. I mean what fundamental security assumptions are no longer valid when something else goes wrong. We used to call this defense in depth. Now we called it building to reduce blast radius. It all means roughly the same thing, which is making it as hard as possible for an attacker to turn one vulnerability in one part of your application into a successful attack on another. A brief aside on containers, I love containers. They help a lot when it comes to reducing the blast radius. You can use some really cool security features. You can lock them down to only access certain kernel, what's the word? That's right. You can lock them down to only access certain syscalls. You can make their file systems read-only. The Kubernetes networking plugins can provide good policies to limit access. And then there's products built on top of the whole thing, like Istio, that can provide great encryption of all these inter-container communication and can provide a management layer. But in real life, these containers have to interact with each other, and they also have to interact with other cloud services. And once you do that, you find yourself back at square one, which was credential management is hard. When I'm building a cloud-native application, I care about the credentials and I care about blast radius, but that doesn't mean I want to manage the individual life cycles of every secret and every key that my identity system relies on. I do want to make these broad security statements, like this component can only talk to that thing, this cloud service only has access to this role or can call this one API. The implementation details of credential lifecycle management and key lifecycle management should be automatic, and it should be managed by the cloud provider. I guess what I'm saying is the best way to solve the credential management problem is to get somebody else to do it for you. especially if they'll be a fool enough to stand up on stage and volunteer to do it. There's so many edge cases to consider. There's so many best practices to be aware of and to enforce. I would want a whole team of people that were dedicated to its design and maintenance. Okay, my turn for audience participation, although I can barely see you. So who has used a Kubernetes service account or an IAM service account on any cloud provider? All right, now I want you to keep your hands up if you've ever built your own identity system from scratch. Okay, so there's a couple of you, that's awesome. Towards the end of the talk, I'm gonna come back up and we can nerd out on implementation. Until then, stand by. Go. Right, so Shopify was really, really great to work with on this problem space. They have, like Jonathan mentioned, this habit of pushing on all the bits of our service we maybe didn't expect to get pushed on that hard. When we talked about this set of problems, their perspective was really valuable to the eventual design we landed on. We heard from Jonathan and many others that the process of accessing Google Cloud Services from within Kubernetes engine was really onerous, that managing these long-lived secrets and all these IAM service accounts was very painful. And then additionally, as security professionals, neither myself nor Jonathan were happy with all these keys just flying around everywhere, either being unmanaged entirely or being managed in a decentralized way. So we decided to take a crack at the solution, and this is what we came up with. Today, I'm introducing Workload Identity. It'll be in beta in a few weeks, and it's designed to help people like Jonathan and Emily, and also for all the security folks in the room to help you sleep a little better at night. Last year, I gave a big speech about trust and how using a cloud provider is an exercise in trust. I think part of that relationship is we need to offer services for you to build on top of that are built on really strong security principles. So Workload Identity makes it easy to access Google Cloud products from within Kubernetes engine without becoming an expert in identity, and without becoming an expert in credential management. You don't have to manage any keys or any secrets. Related to this, we have this new concept called an identity namespace, and I'll go into exactly what that means more in a minute. But in short, it's gonna allow you to define the relationship between Kubernetes workloads and the Google Cloud identities that they should use without a bunch of excess micromanagement. It's gonna work across clusters, and it works with the existing Google client libraries that you're probably already using. I think if you're gonna get someone else to solve a problem like this for you, it's only fair that you understand the kinds of principles that led to the design they ended up with. I like sharing principles like this. I think it builds a lot of trust, and I think it helps you understand why we made the trade-offs we did, and maybe even give you a little insight into the direction that we're going. So the first major principle we designed towards was least privilege. All that really means is not giving any one component more permissions than it actually needs. In this instance, it means we can't force you to be less stringy with your permissions than you want to be. And specifically, that means we couldn't rely on the underlying virtual machine's service account identity because of the way Kubernetes scheduling works. Your workload could end up scheduled on any given node, and in that case, you would have to grant too many permissions to the underlying node. Secondly, if a component that's running workload identity gets compromised, we need its blast radius to be like as small as possible. We primarily achieve this by making sure the long-lived durable secrets that underpin this whole system are never exposed to workloads at all, and the access tokens that we do expose expire very quickly. And finally, I wanted the solution to play nice with Kubernetes. Kubernetes engine customers are probably our customers because they love Kubernetes. So we wanted to design the solution in a way that fit in seamlessly and followed the best practices and the way that Kubernetes likes to do things. All right, so if we're gonna integrate seamlessly with Kubernetes, and if we're gonna build this identity system, let's take a brief aside and look at what we have to work with. This is like a Kubernetes cluster. You've probably seen it before. It's got a control plane, it's got nodes. Nodes have pods. Your workload lives in those pods. Got a bunch of API objects. I didn't think we'd have a screen this big, so you probably can read them. On the left, we've got a bunch that result in the creation of pods. And then on the right, you've got a bunch that provide various controls for your cluster. The one that we actually care about in this case is the service account. So The Kubernetes service account is a really good junction point for Kubernetes identities and Google Cloud identities. You can create them really easily, just a couple of lines of YAML. You can associate them with a workload with like one line in your config file. And I think most importantly, you can set them up as the default for an entire Kubernetes namespace. That can be really useful if you have a complicated or large infrastructure to manage. Except your environment probably didn't look like that. I'm assuming that most environments look more like this. We've got multiple clusters. They're talking to each other. They're talking to Google Cloud. They're talking to multiple cloud providers. And we wanted the solution that we build to be something that works for the real world, for you. So enter the identity namespace. And this is my perfectly accurate and entirely incomprehensible definition. Jonathan stole my other definition slide, so I'm keeping this one. I know it's usually easier to go through these things by explaining what they do rather than what they are, but we're gonna use this one anyway. An identity namespace is a scope in which a name uniquely identifies a principal. And what I mean by scope is we're gonna be using this identity namespace to define a collection of other things. And within that collection, anything with the same name is actually the same thing. So you can imagine it's like a magic room where everybody named Alice is actually the same person. It's kind of a strange concept in the abstract, but it has some really useful principles that we'll get into. And this is what it looks like in real life. So when you enable workload identity on your cluster, your Google Cloud project gets an identity namespace. And within that namespace, you can identify your Kubernetes service accounts by a combination of their Kubernetes namespace and service account name. Because the combination of a name and its identity namespace is globally unique, and because the things that we're naming are Kubernetes service accounts, this means we can treat Alice in cluster A and Alice in cluster B as the same person. And for all the crypto nerds in the room, there is no Bob or Eve in the story at all. All right, so consider this simplified example. We've got two Kubernetes clusters, each have two pods, each have two namespaces, each have two service accounts. They're completely independent from an authorization standpoint. The identities that exist in these clusters are only relevant inside these clusters. But if we bind both of these to the same identity namespace, then we can start thinking about logging robot from an external context. We can start thinking about logging robot as the same in both Kubernetes cluster 1 and Kubernetes cluster 2. If you toss in a little Google magic, we can then associate logging robot with a Google service account and use it to access cloud services. All right, so I'm gonna assume at this point the audience is relatively split down the middle between the how does that work group and the show me how to use it group. So next up, Mike's gonna come up here and demo how it all works in practice with a live example, assuming the demo's working. And then I'll come back up and we can do an architectural lightning round for all the architecture nerds. And that's it.
Cool. I'm a Mike, yeah. Oh wait, one more slide. Thank you. I have, this is my example app. It's actually a little bit faded than it was, but there are a couple more boxes. So in GKE US West, there's a box around the entire thing, and that represents my GKE cluster running in US West. There's another box around it, Fuzzy Llama and GCS server. So I have this app running in the Fuzzy Llama namespace, running as the GCS server service account. I use the GCP project name generator to get Fuzzy Llama. And then I have another GKE cluster running in an eastern zone, and it has a namespace Fuzzy Llama and my GCS server app running inside of it. And this is all running in my project Mike Denis K8s. So what these apps do is they read an object from GCS and serve it to my customers. So it's a pretty sophisticated app, but we're going to try to set it up in this demo. So if you can switch to the other screen now. Awesome. So let's get started. First thing I'm going to do is I'm going to deploy a cluster. How's the size for everybody? Would you like it a little bit bigger? All right, thank you. So I'm deploying an app to, or a cluster to US West 1B. If you'll notice, I'm passing this flag, identity namespace equals Mike Denis dash KDS. So this is my project-wide identity namespace. So I actually pre-created this cluster because it's a bit slow. And the next thing I'm going to do is I'm going to show you my app. It's a pretty concise app. The yellow is the important part. So I'm using the Google's Cloud SDK, just the default client libraries, to construct a token source. If you are familiar with how the token source works in Compute Engine, it just reads the token from the metadata server. I then grab an auth client that uses that token source, and then I read one object from GCS. So if we hop over to my Kubernetes config, all I really have is a service. It's a load balance service that is serving on port 80 to expose my app to the customer. I have a service count named GCS server running in the fuzzy llama namespace. And I have an annotation on that service account that says, I want to run as the GCS server GCP IAM service account. So this service account has not been created yet. And then at the very bottom, I have my deployment that runs the app that we just looked at as my GCS server Kubernetes service account. So pretty straightforward. Let's see if we can get it running. So first thing I'm going to do is I'm going to create that GCS server service account. And I'm going to grab credentials for my cluster and apply that application config. And then make sure that that app is coming up. So give it a couple seconds. Looks like the GCS server app is deployed. And the next thing I'm going to do is I'm going to give my Kubernetes service account permission to run as the GCS server account, GCS server IAM service account. So this is a bit dense, so I'll unpack it. We are adding an IAM policy that grants GCS server in the fuzzy llama namespace in the Mike Denis -KDS identity namespace token creator permission on the IAM service account that we want that app to run as. So this actually is the step that grants my Kubernetes service account permission to use the IAM service account. So that looks good. Next thing I'm going to do is I'm going to pull that app in my West cluster. And I'm getting 403 forbidden. Well, that's probably because we haven't given my application permission to read that object. So next thing I'm going to do is I'm going to use gsutil change ACL to grant that GCP service count permission to read that image or that object. And we get kind of what we expect. I'll also notice this will be important when we set up the second half of the demo, that the cluster name is exposed as a red header. So let's go set up the second half of the demo. So I'm going to do the exact same thing. The cluster is called East, but it's deployed in US Central. I actually also pre-created this cluster. So next thing I'm going to do is I'm going to grab credentials for it. And then I'm going to apply the same application config. And make sure it's running. Looks pretty good. And then what I'm going to do is I'm going to pull East and West at the same time. So as you can see, this one hit West, that one hit East. So both my applications are able to read GCS, that GCS object. The reason we didn't have to add any ACLs to set up the Eastern cluster is because both clusters are in the same identity namespace. So Google authenticates them as the same service account. So the last thing that we will do in this demo is I'm going to revoke ACL, and just to bring that principle home, this ACL revoke will apply to both clusters simultaneously. So West just failed, and East just failed. So West and East are running the same service. My GCS server application spans both those clusters. And that's the demo. Thank you. Awesome.
Okay, I promised you an architectural lightning round. For those of you who kept your hands up in the beginning, this bit's for you. There are 5 fundamental new components that exist as a part of this new feature. First, we have an OIDC provider that runs on Google's infrastructure. It provides cluster-specific metadata, and it signs JOTs. There is a new GKE metadata server. It runs as a daemon set, meaning one instance on every node. It emulates the existing VM's metadata server, but it exposes pod-specific data. This is going to provide backwards compatibility with old client libraries. Right, and it also offers like built-in metadata concealment, and if you are familiar with that feature that's in beta today on GKE, it isolates some secrets that exist in the GCE metadata server from being exposed to your workloads. This is built into this new metadata server as well. We also have a new annotation that you saw earlier on the service accounts, that you indicate which GCP service account you want to act as. That's not actually a security boundary, but we do need it to provide the hint. And then, of course, we have Google IAM. It issues access tokens. It validates bindings. The new thing is it also validates OIDC signatures now. And then Google Cloud at large, it accepts access tokens, and it does pretty much anything. We're going to walk through the flow now. There's 2 steps that are left out, and that's an authorized user binding the cluster to the namespace. You saw Mike do that earlier. And the second is the workload needs to try and do something, to try and access a Google Cloud service using a client library. Once that happens, the GKE metadata server is going to request an OIDC signed JOT from the control plane. And then, oh, I'm sorry, I should note that connection is authenticated using mutual TLS, and it uses the node's identity as the client cert. Then the GKE metadata server is going to use that OIDC signed JOT to request an access token for the identity namespace / Kubernetes service account from IAM. IAM is going to validate that the appropriate bindings exist, and then it's going to validate that it was signed by the cluster's correct OIDC provider. It's then going to return an access token, and this access token, remember, is for the identity namespace / Kubernetes service account. Then the metadata server is going to send that access token it just got back to IAM, and IAM is going to exchange that for a short-lived GCP service account token after validating the appropriate bindings, of course. Then the GKE metadata server returns that token up to the workload, and the workload can obviously use that to make calls to any GCP service. There's a lot of token exchanges and validations going on, but in practice, what this means is once you've done the configuration and set up your identity namespace, your identity in Google Cloud is determined by the Kubernetes service account that your workload is running as, and everything else just works.